start filling out that table now, please? And we're ending early too.
That's what she said.
They have to go down to the team panel. What number should you start here with, Henri? Here.
41.
Fabian? 40 what? 45? He's giving him a 45-meter head start. So that's where Henri starts his race, at the 45-meter mark. Because he has been given a 45-meter head start on my desk. Emil, on the other hand, is going to start at 0. Remember, he goes 1 meter per second walking. Emil goes 2.5 meters per second walking. So reminding you of that, then we need to fill in the rest of this table. That's 45 plus 5 is 50. 45 plus 10, 55, 60, 65, 70, 75, 80, 85, 90. I think that's as much of the table as they gave you down to 45 meters, or down to 45 seconds. That's the timeline. So now for Emil, he starts at 0, and from 0, after 5 seconds, that's 2.5 times 5.
I already got it.
So now you're going to go 2.5 times 10, and you're going to fill in this row. 2.5 times 15.
37.5.
Selena?
50. 60, 75. 87.5. 100. 112.
So once you have done your calculations, this should be your table filled in. Once you have your table filled in, you can plot those points on that graph. And you don't have to wait for me to do that. You're doing both.
Can we use a marker for it?
You need 2 colored pencils. Or you can do it in the same. Doesn't matter. Yes. Across the bottom, that's time in seconds. Up the side, that is distance in meters. I would number across the bottom maybe every 5 seconds with the amount of space that they gave you. And then up the side, I would go about every 10 meters. Yes.
So sorry.
So we're numbering at the side every 10. I'm up here. I'm not back there. Not facing back. No, you can't. At 0 seconds, Henri is at 45 meters because he got that head start. So you're going to 0 seconds and up to 45, and that's where you're putting his first dot. At 5 seconds, he's at 50 meters. So you're going over to 5 and up to 50, and that's where you're putting the dot. At 15, you're up, no, we're at 10. At 10, you're up to 55. Then you're up to 60. Then you're up to 65. And then once you got it plotted, that's Henri's line.
I thought that said red.
Now you plot Emil. At 0 seconds, you're at 0 meters. At 5, you're at 12.5. At 10, you're at 25. At 15, you're at 37.5. At 50. At 25, you're at 62.5. At 30, you're at 75. $87.5. 100 and 112. And then you will connect Emil. Yes. So we've got our table done. We can tell it is linear because it is a consistent increase per interval. It is with Henri by 1 meter per second, and it is with Emil by 2.5 meters per second, and it is an increase so that we know our line is going to go upward. And because it is a consistent rate of change each time, we know that it's a linear relationship. Now, by looking at the graph, we know it's linear because they're straight lines. And if we look at the equation, remember that the equation to be linear must be in the form of y equals mx plus b. Henri had a head start. He's got a B. His distance is 45 where he started, plus 1 meter for every second. So he really does have his in the form of y equal to mx plus b. Now, Emil, on the other hand, didn't get a head start. He doesn't have a B. His B is 0. He does have 1, but it's going to be 0. So when we write his equation, Emil is going to be 2.5 times the second, each second, because that's the rate at which he can go. So our focus question was, how does the pattern of change for a linear relationship appear in a table? How does it appear in a graph? And how does it appear in an equation? Yes? It's A1, A2, and A3. It says draw a table. That's filling in the table on the back. It says draw a graph. We done that on the back. It says write an equation. Now, it doesn't really help you to do all this unless you understand what it all means. And I'm going to explain it to you, and then you're going to answer the question. Yes, Andrea? Yes. It asks one of the questions, what is the distance between the two lines represented on the table? What does the distance represent? What does this dot on the circle represent?
I was going to say that there was
This dot is where Emil catches up with Henri. So, this distance is how far apart they are in the race. If this one started at the 45 meter mark, this one started at the 0 mark, this means how far they are at each point in the race. That means it's going to take how many seconds for him to catch up to him? Time, 30. It takes 30 seconds for him to catch up to him. So we know that the race has to be at least 30 seconds long. That's the whole question you were trying to answer. How long should the race be for Emile to catch up with Henri but still allow Henri to win, but just win? So it can't be longer than 30 seconds, or Emile will take over and he will win the race. How many meters should it be at least? At least 75 meters long. Because even on the table we see that at 30 seconds they're both at the same meter mark. So we can see on the table that this is where he catches up to him and this is where he starts going further than him. Because he does walk at a faster rate. So that's what this intersection means, and tomorrow's lesson is all about the y-intercept. This is y-intercept form. It helps you identify certain things. So we can tell by looking at the table what needs to happen. We can tell by looking at the graph what needs to happen. It wants to know how can the pattern of change for a linear relationship appear in an equation. That's part of our focus question. Your rate of change is going to be the coefficient that's next to the variable. The coefficient that's next to the variable. That's going to be your rate of change. Some of your questions you're fixing to answer on your own talks about how do you tell which one is the steeper line in the graph. The person that's going faster creates the steeper line. How do you know who's going faster? Just by looking at the equation. Because it's the one where the coefficient is the bigger absolute value, the furthest from 0, is going to create your steeper line. So we can see here in the equation that Emile, because his is 2.5 and his is 1, his is going to make the steeper line. We can tell here that this is the steeper line. And again, it's Emile. We can tell on the table because at the same mark, the one that's got the higher one at the same time will have the steeper line. And again, all three of them, the table, the graph, and the equation, points to Emile having the steeper line. Yes. You guys are going to have to start taking care of this at lunch and when you get back from lunch. And quit asking during math time. Most of you come to me from a class that is not tested anyway. Go use the bathroom and spend your time in the bathroom during those classes and not in math. I'm going to start saying no, and you're going to start losing points for asking. Take care of it on your time. Are there any questions? Because going through this together got most of it done for you. All you're going to have to do now is read through the questions on page 30 and 31 and answer the rest of the questions on the recording sheet based on what I've already told you, because I've given you all the answers just in discussion. Now what you're going to have to do is just take what you know now about the three things that are up here, the table, the graph, and the equations, and answer those questions. On page 30 and 31, you're answering 2.2. Any questions before you start working on the question? Okay, if you have a question as you're working, raise your hand and I'll come around and help you. Say it again. Hurry up. At 1:45. I need for those who have already copied the table and the graph and wrote the equations to pack your bag.